Welcome back, everyone. It's been a number of weeks since I produced a video, largely because I have been participating in Epic's Art Jam Project Titan. And that was an experiment by Epic to bring the community together to build a really big world. And so that took my attention for quite some time, but I thought I'd come back and share some of the things I learned in going through that experience with you guys. So first of all, what was the Art Jam? If you're not familiar with Project Titan, it was a 10-week challenge that picked up at the end of March and just wrapped up here at the beginning of June. There were thousands of participants in the project, so we were all building an immersive world together all at the same time. They were pushing a 8K by 8K world with lots of biomes. Essentially, it was controlled chaos by a handful of folks over at Epic that did an outstanding job of educating us, mentoring us, and teaching us, and chastising us when we were doing things that were impacting performance. What I took away from that project, a couple of things. I got much more familiar with world partition and got a chance to see that in real dev environments. The use of HLODs for performance reasons, and dependency on level instances, using the one file per actor, how to merge actors, how to use a packed level actor, and a lot of things on nanite optimization. So the Titan project videos are out there on YouTube if you wanted to follow along over the last 10 weeks. What I was going to do in this video is really touch on three of those things. And that is sort of the level instance, how to create them, when to use them, what are some of the benefits of a level instance, particularly in a large scale open world model. What about merge mesh? How do you merge some meshes together? It's actually merge actor is the official tag. But what does it do? How do you use it? And then this concept of a packed level actor, and we'll touch on that and how it does. So again, this is sort of a summary of my experiences on Project Titan. I'm doing this because I'm waiting on a new computer as a result of painfully working through Project Titan on my current computer. I realized I need a new one. And so I thought I'd put this video together while I wait for that to arrive. So let's jump right into it. So let's start with the concept of a level instance and the one file, per actor concept. So when you have a really large world and you're working on an area of the map, it's not uncommon for a level designer to stack sort of lots of meshes of similar styles and rotating them to create a piece of geometry in the world. And so in my case, we've set up this little island, and in order to make it a little more interesting, I've used these meshes, and we're going to ignore all the stuff in the folders. And I have these 15 rocks that are in this general area. And in fact, if I browse to those assets, I may include some more and scale that one up a little bit. That's a little small. So you're basically working in your level, and this is very common, and you're building up this geometry to make it look the way you want it to look, and so the player can interact with it, either get up or down. And this is what most of us do when we're starting out a map. The challenge with this is if I want to make another mountain like this, I would basically have to find all these rocks, and in a very large outline that could be difficult. I'd copy it, paste it, drag it over here, do my rotation, scale, whatever I want it to do, and then I have two sets of rocks. And what that basically means now is I have all of these original meshes, and now I've duplicated and I have a bunch more meshes. So I'm going to delete that, but that's how we might go about working on a level. Instead, what I'm going to do is I'm going to take these rocks and I'm going to convert those into a level instance. So I'm going to select the meshes that I want, and I'm going to right click to level, and I'm going to create a level instance from my selected assets. And what it's asking me to do here is set the location of the pivot point of this level instance, which is basically a map within a map. And so by default, it's going to be in the center of these meshes at the lowest possible Z. And that works fine for our case. So we're going to go ahead and do that. And it's going to prompt us to name it. I like to call mine level instance rock formation A. So here's our rock formation A. It's a level instance, and we're going to hit save. So while nothing looks different in the scene, if we look at the outlier, we'll see that we now have this level instance icon, and underneath it, grayed out, are those 15 meshes. And so what we did is we created this level instance and replaced the individual assets with this level instance asset right here. And in doing that, we also created, under maps, under level instance, we also created this level instance map, which is nothing more than a map. And if I were to open that, you'll see the meshes in the map. And at this point, there's a couple of things you could be doing around a level instance. Some people like to maybe open the level instance, and you'll note right away that it just went black. It's because there are no lights in this level instance. So you go to unlit, and there you see that I have the map open. And in the outliner, I have all of these rocks. And I could take this rock here and sort of call it the front rock. And then this one we'll call the top rock. I'm not going to do this for everything. But I'm working inside this map and making any changes I want to make to this formation. The problem with this is it's really hard to see in context of where it's going to look in the world. And so as you're tweaking and adjusting things here, it gets hard to see how that plays out. So I'm going to go back to the map that we were working with. It's this one right here. And so this is the map, and I'm going to go back to being lit. And our level instance here, you'll note that the front rock and top rock are carried over. But I can right click this in the parent map, and I can say edit level instance formation A. And you'll note that the rest of the map went gray. Now that's a setting that you can change, but what it does is it allows you to see in context where your level instance sits within the broader world. And I find this to be very handy when working on a piece of a map. In fact, one of the things we did in Titan is made sure that everyone was working within their own level instance so that we didn't have a lot of conflict across the 1,000 or so people that were working on the map. So as you're working in your level instance in this setting, again, I could be taking rocks like this and copying it, pasting it, dragging it, maybe rotating it, and doing whatever I need to do sort of in context of the world. I can kind of see where it sits in the ground plane. I can get a visual of it like that. Maybe I'm working over on this side and I'm trying to see that I don't particularly like the way this looks, so I might push it down into the ground a little bit more. So basically editing inside the level instance. And then as you're doing that, when you hit exit, so as you're doing that, you actually have these unsaved assets. That's because we're using, I always get this wrong. one file per actor, which means for each one of these, there's an individual file. So I'm going to I need to do some more changes here to make this a little more evident. I'm going to copy and paste that. I'm just going to drag that over here. And I'm going to scale it a little bit this way, scale it a little bit that way, and just move that. So I'm putting this sort of rock in this back corner here. And I'm basically just filling out my formation. All right, so now I have 3 unsaved assets. And as I click on that, you'll see that the 3 assets are external actors. Let's see if I can make this bigger. And they have this sort of generated name, but if I hover over it, you can see they are under the level instance, under LI rock formation A, and then they have this generated name. So these 3 files represent the 3 rocks that I just moved around. So if I save those 3 rocks, they're all saved. Save my level instance. If I duplicate another one, let's duplicate this one. You'll note down here, we'll go from Control C to Control V. We now have one unsaved file. I'm going to drag that around a little bit, move it into the position I want. It's not my best work. I'm just trying to give you an idea. And then when I save and exit my level instance, you're going to see that it's going to say, do you want to save that one change, which I will do. And now all the assets are saved. So here we have a level instance, and we can actually put a second level instance in. So if I go to my level instance folder now, or if I just want to copy this, so I can just do Control C and Control V. And what I've done is I've duplicated the level instance. And you'll note here there's one unsaved asset because it's the level instance that I'm duplicating. I'm dragging that over there. And so now I've duplicated that whole construct. And in fact, what I've just done is rather than copy all the static meshes, I made 2 level instance actors in the world, which underneath each of those are the meshes. So if you look at my outliner, I have my level instance 1 and my level instance 2. So using the level instance allows you to move things around. And then if I were to right click this one and edit it, and let's take this top piece and drag it up and hit exit and save. Note that this top piece moved as well, because editing this level instance is really just editing this right here. And so no matter which of these 2 I edit, if I push that down, a bit more normal, you'll see that they both are being reflected. So using the level instance is a good way to organize chunks of work, either for version control to keep different folks working in the project, not stepping on each other, where you might be duplicating chunks of work across the world, and you want them to be the exact same, and therefore if I make a change to one, I want the change to happen to another. So a level instance is a much cleaner way to basically do that than having all of these static meshes in the world. Now, so that's the level instance, and it has its advantages. It does have a few disadvantages in that it is still at runtime going to render each individual mesh in both mountains. So both mountains are made up of 15 individual meshes, and therefore with Nanite, let's go to our Nanite not mask. When we're looking at our triangles, we're getting basically the stacked up meshes. You can kind of see it here that the topology is kind of like one and then the other is right here. And if you look at that with the Nanite overdraw, you're going to see that both have, not horrible, but they have overdraw. I mean, they're not as bad as these trees, which are really bad from an overdraw perspective. But you can see in here, there's some overdraw where these meshes are combined. So a level instance does nothing to basically solve for nanite overdraw, but it is a good way to construct your levels so that you can be a bit more efficient and you can work in a more organized fashion. All right, so the next thing we're going to do is actually tackle that nanite overdraw. And we're going to use the merge mesh for that. So when we do a merge mesh, so let me first get rid of this one. I'm going to delete that level instance. Let me do it with these 3 rocks as a first example. So I'm going to copy those 3 rocks and drag them over here. And let's assume that this was a much bigger piece of geometry and there was, dozens of pieces in this geometry. So you got all done building this beautiful piece of your level. You've got these 3 static meshes, and you're going to go up under, with the 3 of them highlighted, you're going to go up under actor, and then you're going to do merge actors, and then we can do a merge, simplify, I don't really use those 2, or merge actor, and then pop up the settings. So if you click the bottom one, it's going to say, okay, you want to merge these 3 actors together, and here are the things you want to do, right? So you set some values for how you want stuff to happen, including whether or not you want the resulting mesh to be nanite, and basically you can do whatever you want. Down here at the bottom, there's a button that says replace source actor. And when you check that, what happens in your world is I'm going to merge these. It's going to ask me to save the new mesh. I'm just going to save it right here, which is going to be merged 3 rocks, just so I remember. And I think I just close that now. In the content drawer, I end up with this new merged 3 rocks static mesh, which is exactly that static mesh. So you can see here that it is now 1 mesh instead of 3 of the same mesh. They all use the same material, so it put the materials together. And as a side effect, if you look at the collision, I didn't have simple collision on this one, it would recast your simple collision over this more complicated mesh. Whatever reason I had complex on those rocks. So let's undo that. All right. So the downside of that is this is now a single mesh. And I can't go back and tweak this unless I had saved those 3 rocks somewhere. Now, for us, we have 3 rocks right here. And so the downside of the merge mesh is that, you have to move these rocks. So the downside of the merge, so this is our merged, is you have to keep your original rocks somewhere, or else you're not going to be able to, you can't unmerge these. It's created a brand new static mesh. So if you found that, you really didn't want it to look like that, and you wanted this to be, rotated in a slightly different direction, you're not going to be able to do that unless you save the original configuration somewhere. So if I make my 4 rock configuration like this, right, and I make this one maybe a little bigger, I could then save this as another merged mesh. The nice thing with the merge mesh, though, is if I copy it and paste it, I'm basically just making a single mesh copy and paste. And so the merge mesh is good once you've created a formation you're confident that that formation is going to be consistent, or that you saved off the source file for that merged mesh either in a different level or something else. I like to use a level instance so that you can always come back and edit it and create a new mesh. So in this case, we use the merge mesh, and we didn't use the simplify, we just used the standard, and that created a mesh, right? So that created this single mesh right here, nothing else. I say that for a reason. So I'm going to go ahead and delete that. In fact, I'm going to delete these because I'm going to use the level instance. And I'm going to remember to delete that static mesh because I don't want to keep that. All right, so now remember our level instance here that we have in our scene. It's a level instance. It's made up of several meshes. I'm actually going to use that, and I'm going to simplify and merge this into a single static mesh. And the reason I'm going to do that is when we looked at the nanite overdraw, we saw this sort of pinkish tones down through the middle indicating overdraw. So I'm going to select this level instance. Can I do the merge? No, and then go up to actor. I'm going to merge, and this, you have to be very careful with this merge that you don't destroy your level instance. In fact, I'm so paranoid on the number of times that I've done that I'm going to go in here and I'm going to save a copy of that. So right now in my level, I have a level instance. It's made up of all these rocks. I'm going to select it. I'm going to go to actor. I'm going to go down to merge actors, and I'm going to go to simplify. Once again, it's going to ask me where do I want to put the simplified asset. I'm going to go into, in fact, this time what I'm going to do is I'm going to put it in a folder. Merge, level instance, new folder. Yeah, new folder. Simplified merge, and we're going to call this rock formation B merged, or rock formation A, I think it was. And what this is going to do is it's going to use a projection technique to build a brand new mesh of the outer edges of these meshes, and it's going to generate a new material and some new textures. And so what it does is it creates 4 assets for you: the actual static mesh here, the material, this material instance here, and the rock texture and the corresponding normal. Because it's merging together multiple assets, it's going to generate these two files. So now, if I did that correctly, this is still a level instance. Good. So this is still a level instance. It did not replace it, which is what I was afraid it might do. And then over here, I'm going to drag our new mesh in and try to get these as close to each other as I can. You'll first notice that it's a little shinier. So during the process, you do sort of, I lost some of the flatness of my material. But again, I could go into this and you can see that the texture, while close, doesn't quite resemble what I want from a visualization. So our mesh is correct in that it has the proportions and looks proper in the way that the mesh merged. There's a gap there is a gap there, so that gap is proper. I'm not thrilled with the texture work, but again, I can go in and see if I can't edit. Let's get our original texture out here. What is a texture on these rocks? MI landscape rocks. MI landscape rocks. And on this one is our new which has the flattened material as the base. So this came from Unreal. These again are meant to be sort of assets that you might have off into the distance. But what I wanted to do was show you when I put these two side by side, and I go into the nanite triangles. That's what I thought. Hold on. Enable nanite on. There we go. I'm going to save all of that. So now that we have the two meshes enabled in nanite, if we go to the nanite overdraw, you'll see that the merged mesh doesn't have nearly the overdraw that the level instance does. So to the extent that you're looking to reduce overdraw to make nanite more efficient, a merge mesh is a good way to at least pull your geometry together. I would recommend that you then maybe take this, unwrap the UVs again, and apply your materials again so that you get the right sheen that the other one has. But basically, rather than having 15 meshes, you now have a single mesh. And then again, you could copy and paste that single mesh wherever you needed it to be. So these are two meshes, and these are two level instances, and they'll perform differently, right? This one will have more draw calls because there's about 15 meshes in the level instance, where this one has one mesh. This has more overdraw. These have less overdraw. So there are some performance things to think about, but these really can't be changed unless you go through the process of saying, I'm going to delete that. Let's say I wanted to change these meshes. I would basically go into my level instance, edit it, move pieces around. Then I would do the process to select it, go to the actor, do a merge again, do a new simplify, create a new mesh, and replace these meshes by basically clicking on them and saying, replace this mesh with whatever the new one is. So you can do it. It's just more steps into the process. The real benefit is in reducing the overdraw. And then again, of course, you can take this into the modeling tool and basically start to do whatever you needed to do on it from like either remesh it or redo the UVs on it. Any of the things that you might want to do to fix it. You may want to do some texture painting, but basically that's how to use a mesh merge or an actor merge and create an asset from a level instance or just a series of static meshes in your level. The last thing we're going to talk about is a packed level actor. And a packed level actor is basically a blueprint that can be automatically generated from a level instance that uses instant static meshes as opposed to regular static meshes to optimize at runtime the drawing of the meshes by, and you can research ISM or instant static mesh to understand the differences between regular meshes and instant static meshes. But I'm going to go through the process here of showing you how to convert my level instance into a packed level instance and a packed level actor. So I've gone ahead and deleted the other stuff out of the scene. I've got my level instance, and there may be another way to do this, but this is the method that I found works best. I'm going to right click on it, go down to level, and I'm going to do break. In fact, I could try creating a pack level instance, but this is what I typically do. I typically break it back into its component pieces. And so I'm going to break this level instance. It warns me that it can't be undone. And now I have the individual meshes again in the world. So it took the level instance out of the hierarchy and gave me our rocks back as static meshes. And I did that so that I could then right click this exact same pile and go down and create not a level instance, but a pack level actor. And when I do that, we're going to end up creating two two things in the content folder. So new pack level actor, basically the same as doing a level instance. Where do I want the pivot point? And I'm going to go ahead and say yes. Now in this case, the first thing it's asking me to do is what do I want to save the level as? And this is where I probably could have took the level instance and did something with that. I like to call it a pack level instance. And this is going to be rock formation B, even though it's exactly the same. And so the first thing I'm doing is saying, okay, I want you to save a level instance of these 15 objects like this. And then it's going to say, okay, where do you want to save the asset? And by default, it puts a BPP in front of it. I have a preference for pack level actor. So I have a pack level instance and a pack level actor. That way they sit side by side in the content folder and I can see them. And so I'm going to hit save on that. Okay. And now I have a pack level instance, which is this rock formation B, and a pack level actor, which is the rock formation B. And you can see the actor is of a blueprint class where this is of a level. And if we look in our Content Explorer, we actually have, their naming convention is a little odd. They call it pack level instance here, but it is a pack level actor. So, and for consistency, this is a pack level actor in this world, which is this now. And if you look at that and you expand the blueprint, much like you would any other blueprint, you'll see that it was generated from this pack level instance right here. And you'll see that it has an instance component on it, and it has an instance static mesh for each of the static meshes that were part of the original source file. So you end up with this this blueprint class, and you could open it right here too. And it is basically the actors that you packed into this blueprint, although using instant static meshes. And you can see here its parent class is the packed level actor. So now I can do the same thing I do with our level instance. I can copy it and paste it. Oh, that was a mistake. Hopefully I didn't, I had a component selected, and that's a no-no. So I'm actually going to delete this out of the scene. I did not save that, so I'm going to drag it back into the scene. So my pack level actor is back into the scene. And if I copy it and paste it, I'm making another copy. So I don't know why my drag is having too many problems. So here I've created two pack level actors, and I've dragged them into the scene, and they're using an instant static mesh. I can also bring in the pack level instance. This will not be as efficient as the pack level actor because these are static meshes. This is no performance, no difference than the level instance. But the reason I wanted to bring that in is I wanted to show you that if you now edit the pack level actor, I want you to see that in fact what you're changing is not the actor, but you're changing the instance. So in this case, it's a long way of saying I'm going to edit this one, and it's going to isolate just like it was a level instance. And in fact, if you look down here, you'll see that it opened the pack level instance. And so if I take this and I drag it up a little bit, watch when I hit save what happens to this pack level actor, this pack level actor, and this pack level instance. They all shifted. So when you edit a pack level actor, you are actually editing its source level instance. And again, if I edit the pack level instance and push it down, you'll note something different. So the first time I changed the pack level actor and all three changed. This time I've changed the pack level instance, and watch the two pack level actors. They didn't change. There's a command for that, which is if you right click this and you go down to level, you can update packed blueprint. And what that'll do is it will read the packed level instance and update the packed level actor in the content browser, which in turn will update these two in our scene. So when we do that, you'll see that the two peaks dropped down to match the packed level instance. So hopefully that's not too confusing, but basically the use of a level instance, the use of a merge actors to create a single mesh, and then the use of a pack level instance and a pack level actor, and how those sort of work together. So again, I can remove these from the level. They are still here on disk in both their pack level instance, pack level actor, and our original level instance. So I can drag that back into a scene at any point in time. That's our level instance. This is our packed level instance, which is tied to our packed actors. So this is the source for any of these that we drop into the world. And then, of course, we had our merged mesh, which is here. And that's the most performant and simplest of the three mountains. So there we have all of them in the scene. And again, I'm actually waiting for a new computer to arrive. When I do that, I'll reload the editor and everything, and we'll do some more videos. But I thought, from my experiences with the Titan project, I got a much better appreciation for level instances and packed level actors and mesh merges. And so I thought I would share that with you guys. So thanks for watching.